Hello, welcome once again to ASMNOF online math class. In this video, we are going to still continue with the application of differentiation, but today we shall channel our attention to tangent and normal to a curve. So we are given a question here, and we are asked to find the equation of the tangent and normal to the curve y is 2x cubed plus 3x squared minus 2x minus 3 at the point where p is equal to we are at the point where x is 1 and y is equal to 0. Now let me just draw a different point apart aside this question. So okay, so this is a curve, your y-axis and x-axis. I'm not making reference to this question, but I just want you to note down the what we mean by the tangent and normal at a curve. This is a curve. You normally experience a curve when you have a cubic or quadratic you normally experience a curve when you experience a cubic, quadratic, quartic, etc. Whenever you have equations that is more than a linear equation from quadratic and above, you must start experiencing a curve. All right, now let's assume that the point they are talking about is point P, at the point where x is 1 and y is 0. I might not use this x is 1 and y is 0 to exemplify. So, but let's assume that this is the point they are talking about, that at this point that x is 1 and y is 0, but not it here. So this point, let's assume that this is the point P they are talking about, okay? So at this point, to get an equation, to get a line that is tangent to this, remember your knowledge of a circle, that when you have a circle, any line touching the circumference of a circle externally at a point, that line is known as a tangent. So equation tangent to this curve is just a straight line which passes through this curve and touches it externally at this particular point they are making reference to. So all you need to do is just to get the gradient of this straight line, take it at any point, change in y over change in x, because the gradient of a straight line is the same thing at any point on the straight line. So you are free to take any point and get the gradient. That gives you the equation of the curve, tangent to this curve. But we don't know our gradient here, so we need to get the gradient. Remember, the curve given to us is y equals 2x cubed plus 3x squared minus 2x minus 3. This is the curve given to us. So to get our gradient, we have to differentiate y with respect to x, because changing y over changing x gives us the gradient. So have dy over dx will give us 2, 3 comes to the back. You have your x 3 minus 1 according to the formula for differentiation, plus 3 is here already, 2 comes to the back. You have your x 2 minus 1 minus, if you differentiate 2x, you are getting just 2. And when you differentiate any constant, you get 0. Okay, so my dy dx is equivalent to 2 times 3 is 6. X, 3 minus 1 is 2. Plus 3 times 2 is 6x. Because 2 minus 1 is 1, no need of writing 1. Then minus 2. This is just the gradient. But an information was given to us. We are told that x is 1 and y is 0. But this equation only contains x. So wherever I see x in this function, I'll put 1 to get my gradient. So dy over dx will now be 6 into 1 all squared, because x is 1, plus 6 into 1, then minus 2. Dy over dx will now be 1 squared is 1, and 1 times 6 is 6, plus 6 times 1 is 6, minus 2. So dy over dx will give me 6 plus 6 is 12, and 12 minus 2 is just 10. So the gradient is 10. Now let us proceed to form the equation of the straight of the tangent to this curve. Now let us use y minus y1 is equal to m into x minus x1. So which I have y minus y1 is given as 0 equals m, my m is now 10, into x minus my x1 is 1. So y will give me, because 0 is nothing, y will give me 10x minus 10. This is just the equation of the tangent to this curve. But we've not finished. They also say that we should get the equation that is tangent to this curve also. Sorry, tangent. We've got the tangent, remaining the equation that is normal to the curve. Now, if you have the curve like this, let me still redraw. This is the curve and this is point P. Here, this is a tangent. Remember, a tangent touches a circle or a circumference at a particular point. So this is the point P where we want to take the equation. Now, any line that is normal to this curve is perpendicular to it. Any line that is normal to this curve is perpendicular to it. So this line is said to be normal to this straight line. Therefore, if two lines are perpendicular, it means that m1, m2 is -1. So m1, m2 is -1. If the slope of one, m1, if you want to get the other persons, it means -1 over m2. So if I want to get even m2 also, I'll write that m2 is -1 over m1. So I will take the first slope, which is our m1, divide the x, I will take it as 10. So if this is 10, it means that my m2, which I require to get the equation that is perpendicular or normal to this curve, will just be -1 all over 10. So let me clean here and continue. Okay, let us proceed to get the equation that is normal to the curve, which I still use the same formula, that y minus y1 is equal to m into x minus x1. So which I have y minus y1, my y1 is 0, equals m, my m is now -1 over 10, into x minus x1 is still 1. So y minus 0 is y equals -1 over 10 into x minus 1. To clear this fraction, multiply through by 10. When I times y by 10, I will get 10y equals 10 times -1 is -10, divided by 10 is -1 into x minus 1. So 10y equals, open the bracket, minus x plus 1. So this is what you are going to get, because when -1 goes into this bracket, you obtain this value. To make y to be isolated, I will divide both sides by 10. So this will just give me y equals minus x plus 1. But I wasted time. Instead of dividing all these values by 10 immediately, I stressed myself to go cross multiplication, but nevertheless we still arrived at the same answer. But look at the pattern here. 10 cancel 10 here, we have minus x over 10 because I'm dividing both sides by 10. So y is now minus x over 10 plus 1 over 10. If you like, you can still write it as y equals -1 over 10x plus 1 over 10, such that the gradient is -1 over 10 and the intercept at the vertical axis is 1 over 10. If you've enjoyed what you've watched, kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out.